exam prep, the most comprehensive app for all exams. Let me know that sound quality, picture quality, everything is fine. Today we are going to discuss a very important topic, that is transient and steady state analysis, right? And this is the series for HPCL exam 2022, and this topic is important for electrical and instrumentation branch, right? And for this particular exam. Now in this session I will give you the idea about the transient, RL circuit, RC circuit, that is called DC transient, and what steady state analysis of the circuit, as well as steady state analysis of the sinusoidal signal also, right? So first of all, inform me that sound quality, picture quality, everything is fine, everything is okay. Yes, please tell me. Right now, my dear friends, this is my introduction. Myself Sanjay Rathi. I am having around 21 plus years of teaching experience, and I have qualified and selected for engineering services exam. These are my ranks: AIR 16 in ESE 2005 and AIR 21 in ESE 2008. And according to my experience, we have to solve number of questions in HPCL, right? Then what will be the level of the question, I will discuss in this session. Okay, with numericals we are going to get the concept on transient and steady state, and I have mentored more than 1 lakh students for these exams. These are my subjects. Okay, now my dear friends, in this session we are going to cover DC transient with numericals. DC transient means RC circuit and what RL circuit, right? As well as I will give you the idea about the RLC circuit, that is the DC transient and steady state. Then sinusoidal signal, you will get the idea about the resonance, steady state analysis of sinusoidal signal. Resonance means series resonance and parallel resonance. Okay, and what in resonance, I will give you the formula for resonance frequency, what is the quality factor, right, bandwidth, and so on, with numericals, right? So ready guys, please use your copy, pen and calculator. Okay, then now in a previous session already I have given you the idea about the two-port network. Please watch my previous session on two-port network and what theorems, all the theorems. I have discussed the complete two-port network and complete theorems in previous 2 classes. Okay, if you want link, then please join my Telegram channel, that is Electronics by Sanjay Rathi. Okay then, so that is the link of my channel, and I will upload the PDF there. Then this is the first question, and with this question I will give you the idea about the RL circuit. What is the RL circuit? For the circuit of the figure, the inductor current IL just before t equal to 0 is, the inductor current IL just before the t equal to 0. Hello, everything is fine? Okay then, now watch this question. In this question, a 10 ampere battery is connected here, 1 ohm resistor is connected here, 3 ohm resistor is connected here, 5 Henry inductor is connected, and exactly at t equal to 0, now we are going to close the switch. So this is the simple RL circuit, a very simple question. So what will be the question? What is the time constant of this circuit? What is the equation of the current for t greater than 0, IT for t greater than 0, or what is the value of the current exactly at t equal to 0 negative or at t equal to 0 positive? So this type of questions on RL circuit. So this question is just simply find the current just before the switching. Just before the switching. To watch this arrow. Now exactly at t equal to 0, the switch will be closed. Means before 0, what about the switch? Switch is open. Then what will be the current in this circuit? So how to find the current? In RL circuit, first of all watch this current. This is the DC current. Means this is the question based on DC transient. First thing. Second thing, that is the case for transient. Always remember, now this point is called t equal to 0, right? And this is the t greater than 0 and that is the t less than 0. So in this question, what is the condition? For t less than 0, the switch was open. So here switch, this is the for t less than 0, switch is open. SW for switch, it is open. Now it is open for long time. Long time means up to from what? Minus infinite we can assume. For long time the switch is open. And exactly at t equal to 0 we are closing the switch. Means for t greater than 0 switch is closed. Now when we are moving from long time or from minus infinite to up to t equal to 0, so just before the switching means that is the time. This time is called 0 negative and this time is called 0 positive. Just before switching, just after switching, 0 negative and 0 positive. And exactly at t equal to 0 there is a transition. The switch will be closed. Now when I am moving from minus infinite to up to this point, up to 0 negative, just before switching, it is a long time. It is a long time for which switch was open. Means circuit reached to what? Steady state. So we can say exactly at 0 negative, circuit is in steady state. Steady state. And just after the switching, now the switch is closed and this is called initial state. Initial state with the switch closed. With the switch closed. Right? Now, what is the nature of the inductor and what is the nature of the capacitor? Under steady state, inductor act as short circuit. Always remember. Inductor act as short circuit and capacitor act as open circuit for DC. For DC. First thing, inductor act as short circuit and capacitor act as open circuit for DC. Second thing, inductor does not allow sudden change of what? Current. And capacitor does not allow sudden change of voltage. So at this point, if we are calculating the current, IL 0 negative is equal to what? IL 0 positive. Means current through the inductor will remain continuous. Continuous means there is no abrupt change in the current through the inductor. Similarly, there will be no abrupt change in the voltage across the capacitor. VC 0 negative is equal to called VC 0 positive. Okay, this is a complete idea about the transient and how to calculate the initial value of the current through the inductor and how to calculate the initial voltage across the capacitor. Right? Now, in this question, inductor is given, the switch is open for long time, means circuit reached to what? Steady state. When circuit reached to steady state, inductor acts as short circuit. So exactly, if we are going to solve it, remember that okay. Now, this switch is open, remove this. Now, this inductor will act as short circuit. So, what will be the circuit here? This is a 10 ampere current source. This is a 1 ohm resistor. and this is a inductor. This will act as short circuit exactly at t equal to 0 negative. Circuit is under steady state, and this is the 1 ohm, this is the 3 ohm. You have to find the current through the inductor. You have to find the current through the inductor. Very, very simple question. So according to current division rule, this is the 10 ampere. So what will be the current through the inductor? 0 negative is equal to IL, 0 positive is equal to 10 divided by 1 plus 3. These are the resistor. If you want the current through the 3 ohm, it should be multiplied with what? 1. So 10 divided by 4, that is answer is what? 2.5 ampere. Answer is 2.5 ampere. Okay, so that is the answer. So which answer is correct? 2.5 ampere. So this type of questions, so remember this is very, very important one. Now for the same circuit, for T0 positive, the current will remain same, that is the 2.5 ampere, but the switch is closed. When the switch is closed, that is the answer is over now. When the switch is closed, only this circuit is applicable, right? Watch this circuit. This is the circuit for t greater than 0. Inductor does not allow sudden change of current, 2.5 ampere. Then what will happen? What is the time constant of this circuit? The time constant of this circuit, 5 and 3, always remember the time constant is L by R, and that will become 5 by 3 seconds. Because it is in Henry, it is in ohm, so 5 by 3 second is the time constant. Means we are calculating the time constant for t greater than 0. So for t greater than 0, since this is the closed, so this is the one circuit and that is the another circuit. The complete current will pass through this short circuit, it will not pass through the inductor, and the inductor will discharge through this 3 ohm resistor. So I think that is also clear. If the time constant is asked, then always calculate the time constant for t greater than 0. Ready guys to solve the new question? Right, that is all about this question. Now, what is the answer for this one? What is the answer for this question? An uncharged capacitor of 0.01 farad. Now, this is the question based on what? Capacitor. First question on inductor, second question on capacitor. An uncharged capacitor of 0.01 farad is charged first by a current of 2 milliampere for 30 seconds. Uncharged capacitor means, always draw a diagram. This is a capacitor. First of all, it is charged by a current source of 2 milliampere for t equal to 30 seconds. Okay, no problem. That is the current. Second time, the same capacitor charged by 4 milliampere current. For what? 30 seconds. Again the time is 30 seconds. Okay. Then what will be the voltage? What will be the final voltage? Very simple. Capacitor does not allow sudden change of voltage. So in first case, because there is no resistor and exactly we are connecting the current, always remember when we are giving the constant current, there will be the linear charging of the capacitor. Remember, there will be the linear charging of the capacitor, means Vc is equal to 1 by C integral of I dt. And this I dt is nothing but what? Q. Q by C. Since the current is constant, there will be the linear charging of the capacitor. This voltage will increases linearly. Now I am going to solve this one. So watch this. Watch the solution for this. Give me the answer. What will be the answer? Okay. Now what is the current here? Current is 2 milliampere for first 30 seconds. And that is 4 milliampere for next 30 seconds. Then what will be the charge in first case? That is equal to 2 into 30, 60 millicoulomb. And what will be the charge in the second? 4 into 30, 120 millicoulomb. So what is the total charge stored? 180. Okay, and that is the value. Now the final voltage in E. Final voltage, always remember what is the relation? Voltage is equal to Q by C. From this formula we are getting the 1 by C integral of what? I dt, 0 to t. Because what is the Q? Q is nothing but I dt. Now V is equal to what is the total charge? 180 millicoulomb. 10 raised to power minus 3. And what is the value of the capacitor? Value of the capacitor is given 0.01 farad. 0.01 farad. Solve this, you are going to get the 18 volt. The answer is very simple, that is what? 18 volt. Everyone please try to solve this question and give me the answer in comments box. Okay, so that is the question on transient, first order transient. Okay then. Everyone please share the link of this session, like the session and subscribe our channel. Okay, now in a HPCL exam you are going to get this type of questions, right? Then again RL circuit, give me the answer without use of calculator. In the circuit below, S was initially open. In the circuit below, S was, means switch was initially open. At time t equal to 0, the switch is closed. Okay. Now, when the switch is open means what is the meaning of this? In this particular circuit, circuit is unenergized. Unenergized means what is the initial current through the inductor? 0. That is the meaning of this when the switch is open. So, initial current IL0 negative is equal to IL0 positive is equal to what? 0. Always remember the time constant of the series RLC circuit is L by R. You have to find the value of the L. So what information is given here? When the current through the inductor is 6 ampere. Okay, when the current through the inductor is 6 ampere. When, this is the complete statement. When the current through the inductor is 6 ampere, at the same time the rate of change of current through the resistor is 6 ampere per second. But these two are connected in series. Very simple, we can say, let this switch is closed, let this is the I, we can write a KVL here. What is the KVL here? When I am writing the KVL, this is the minus 18 volt. Plus, this is the R, always remember Ri, this is multiply, plus, what is the voltage across the inductor? L di by dt. L di by dt is equal to what? 0. So, this is the minus 18 plus R, what is the value of R? 1 ohm. When the current is 6, what is the rate of change? This is the Henry, we have to find the value of L. What is the rate of change of the current? It is also 6. This is given in the question, 6 ampere per second. So, at every instant, KVL should be satisfied. So, simple, you have to satisfy the KVL and that is equal to 0. This is the voltage across the inductor, that is the voltage across the resistor and that is the applied voltage minus 18 volt. If this should be equal to 0, tell me what is the value of the inductor? 18 minus 6 divided by 6, that is nothing but 12 divided by 6, that is the 2 Henry. The value of the inductor is very simple, we can find, that is what? 2 Henry, right? Okay, so in this case we have to simply satisfy the KVL, that is the KVL. 2 Henry is the answer for this question. Now Next one. Okay, give me 1 minute. Now what is the answer for this one? Yes, please. In the circuit shown, the switch is thrown from position A to position B. It was at position A, now the switch is thrown toward position B. When it is connected to A, what is the voltage across the capacitor? Always remember, exactly at t equal to 0, switch is thrown. So before switching, what is the voltage across the capacitor? This is important because capacitor does not allow sudden change of voltage. Because it is connected to ground, that's why capacitor is fully discharged through the ground, and what is the voltage across the capacitor? 0. And it does not allow sudden change of voltage, and that's why after switching it will remain 0 volt. Now we are connecting the 120 ohm, and this is the simple question of what? RC circuit. Simple question of RC circuit, resistor capacitor circuit. So what is the value here? Now when I want to solve this question, very simple one. First of all, we have to find the initial value, then this is the resistor and that is the capacitor. RC, the 3 volt is connected here. What is asked here? In the circuit shown, the switch is thrown from position A to position B at time t equal to 0. The energy in microjoule taken from the 3 volt source to charge the 0.1 microfarad capacitor from 0 to 3 volt. What is the energy taken? Right, try to solve this question. What is the energy taken? Okay. If you want to, what is the total energy taken by the capacitor? If you want to calculate this value, then remember that in this particular question in a RC circuit, 3 important formula always. Under steady state, capacitor acts as open circuit, that's why the complete voltage will come across the capacitor at t equal to infinite. But during the process of charging, the current will flow through the R. If the current will flow through the R, there will be the what? Power dissipation across the resistor. What is the power dissipation? I square R. And that's why there will be the energy dissipation across the resistor. And always remember, energy dissipation across the resistor is given by 0 to infinite PR dt. We have to integrate it. But no need to calculate all this. Remember the formula. During the process of the charging, what is the energy stored in the capacitor? We have the idea. Energy stored in the capacitor is half of CV square. And during the process of charging, energy dissipated across the resistor is also the half of CV square. V means that is the voltage, 3 volt. So what is the total energy delivered by this battery? The total energy delivered is equal to energy stored in the capacitor plus energy dissipated across the capacitor. So it will become half of CV square plus half of CV square. Remember the formula is CV square. This is very important. So always remember, they may ask the question, what is the energy stored in the capacitor? Half of CV square. What is the energy dissipated across the resistor? Half of CV square. And what is the energy given by the battery? If the given by the battery means CV square, then very simple question, if it is the CV square energy, what is the energy taken from the 3 volt source? That is nothing but energy given by the source. So half of CV square, CV square, what is the value of the capacitor? 0.1 microfarad. And it is the energy asked in what? Microjoule. So no need to convert it. 0.1 microfarad into V square means 3 square. Point microjoule. Okay. So number of students are giving the answer 0.45 joule. Why? because the energy stored in the capacitor is half of CV square, and they are ignoring the energy dissipated across what? This resistor. So during process of charging, there will be the energy dissipation across the resistor also. Now, it is independent of value of the resistor. Okay, remember that. It is independent of the value of the resistor. Whether it is a 1 ohm or 10 ohm or 20 ohm, it doesn't matter. Right? Yes. Okay. If your diploma plus degree means you have completed your degree. If you are completed your degree, then yes, you are eligible. Then that is the question. Now next one. Okay. Under steady state analysis, everyone tell me what will be the RMS value. If the very simple question, if it is given, find the RMS value of the current. For any type of question under steady state, they may ask what is the RMS value of the current. What is the RMS value of the current? One minute. No, the RMS value is equal to I is equal to, always remember if there are two signal DC plus AC, so RMS value of the DC plus what? RMS value of the second signal, and square of this. For DC signal, the RMS value is remains same, that is the DC value is the nothing but the RMS value of the DC signal 10 square plus what is the RMS value of the sinusoidal signal? It is a cos, right? This is the representation Vm cos of omega t plus phi or theta we can say. So Vm is the amplitude of this signal that is given as phi, right? And omega, that is called rate of change of the phase. It is the unit is radian per second. And omega is equal to 2 pi f. So what is the value of the omega? 628. Okay, but we have to simplicate the RMS value of the sinusoidal signal. RMS value is given by phi peak divided by root 2, the whole square. Then always remember the RMS value of this signal is Vm by root 2. When I am calculating the Vm by root 2, then it will become 100 plus 25 divided by 2. This is the 25 divided by 2, and this will become root over 225 divided by what? 2. Now you can calculate this value and you are going to get answer 10.6. The 10.6 is the answer for this question. No need to calculate, my dear. If suppose in exam hall you are solving, then try to understand what is the root of 15 into 15, that is the 2, but it is divided by 2, so it is not possible. 5 into 5 is 25, it is not possible, it is not possible, it is not possible. And it is 225 divided by 2 is greater than 100, right? If it is greater than 100, means what is the root of 110? It is greater than that, so definitely the value is what? 10.6. The value is what? 10.6. Remember that. Now tell me what is the equation for 25 cycle current sine wave having RMS value of 30 amperes, right? If it is given that 25 cycles current sine wave, this is a sine wave having the RMS value of 30 amperes, what will be the equation? Okay, give me the answer in comments box. What will be the equation for this question? Very simple one. If I want to write the equation for the current, always remember Vm sine of omega t plus phi, right? That is the equation. RMS value of this is given by Vm by root 2 and omega is given by 2 pi f. Now my dear friends, in this question RMS value is given. So Ashok, you are giving the answer C. Okay, good. In this question RMS value is given. What is the RMS value? 30 amperes. So Vm by root 2 is equal to 30. It is given. So what is the peak value? 30 root 2. You can calculate the 30 root 2, 42.4 it will come. Okay. Then second thing means this answer is not correct, this answer is not correct, these two. Second, what is the omega 2 pi f? When it is asked 25 cycle means what? Frequency per second. This is the cycle, one complete cycle, second cycle and so on, total 25 cycle, right? Within 1 second, 25 cycles 1 second means that is the frequency f, and that is called 25 hertz, right? Cycle per second. So when I am talking about the cycle per second, then what will be the time period of the system will become? The time period is nothing but 1 by f. 1 by f, that is 1 by 25. Now you can put here what is the value of the omega? 2 pi into 25, that is nothing but 50 pi. And phase is not given, that let's take the phi is equal to 0. There is no phase variation. So it will become 42.4 sine of 50 pi t. That is the answer. 50 pi t. Very, very simple representation of this question. Okay. Then next question. Okay, so this type of questions, last one, to a highly inductive circuit. Highly inductive, what is the meaning of this? We are having, no doubt, we are having the resistor and inductor in a particular circuit. Right? But it is written here to a highly inductive circuit means what is the meaning? When we are applying the voltage here and there will be the current, then current lags voltage by 90 degree. That is the meaning of highly inductive circuit. So what is the angle between the inductor and capacitor? Current through the inductor, or angle between the current and voltage? Angle between the current and voltage will be 90 degree, nearly equal to 90 degree. Okay. Now we are introducing one capacitor. When I am introducing capacitor, small capacitance, okay, then now in a capacitive circuit current wants to lead the voltage, and that's why definitely then angle will be decreases. Yes, we are simply neglecting the value of R. Highly inductive circuit means we are neglecting the value of R. Now, so that angle will decrease. So for this question, let's try to understand. If this is a simple RL circuit, there will be the three figures. If simple RL circuit, then what will be the, if the applied voltage is Vs, first of all, let this is the applied voltage Vs, then that will be the current IL. If it is highly inductive circuit, so almost 90 degree, or practically if you are considering the value of R, then that will be the case. Then that will be the case, my dear friends, and that is the lagging angle. This is the current and that is the voltage for RL circuit. Highly inductive means then angle will become minus 90 degree. Current lags the voltage. Okay. If it is purely capacitive circuit, this is the applied voltage, this is the resultant current, then current leads the voltage. Like this is the Vs, this is the I, then for RC circuit that will be the case. Current leads, and if it is a highly capacitive means current lead by what? 90 degree. Current leads the voltage by 90 degree. Or if we are introducing the capacitor inductor both, then always remember angle will reduce, because when it is purely inductive we are getting the minus 90 degree. When we are increasing the capacitor, angle will reduce. This is moving here. When we are introducing the capacitor, always remember this will be the path, right? That is the moment. And when it will become pure capacitive, this phasor will be here. It will reach to here. So that is okay. Now in comments box, everyone please give me the comments on which topic you want the session for HPCL, right? So that is the steady state analysis of the, right? One question on a simple quality factor, last one, the quality factor of a RLC circuit. So in comments box give me the topic, on which topic you want session, right? So that we are going to arrange those session. Okay, in the first session already I have given you the idea about the complete theorems. In second session we have discussed what two-port network, and now that is the session. And if you want extra, then please inform me. Now tell me, the quality factor of a RLC circuit is 5 at its resonance frequency of 1 kHz. Simple RLC circuit has the quality factor. Give me the answer. Let we are applying the voltage here. Okay, quality factor is given as 5. Resonance frequency, that is given in hertz, f0 is equal to 1 kHz. Find the bandwidth of the circuit. Bandwidth means you have to remember each and every formula for what series RLC circuit. RLC circuit, right? What are the formula? First formula, quality factor of the circuit is given by omega naught L by R, or it is also quality factor is given as 1 by omega naught RC. Under resonance, the omega naught is equal to 2 pi f naught. The resonance frequency is given by 1 by root over LC, and this is the resonance frequency. Then the bandwidth is given by omega naught by Q in radian per second. This is nothing but R by L. If you want bandwidth in hertz, then it should be divided by what? 2 pi. It should be divided by what? 2 pi. Now that it is already given in hertz, this is the 5, then you can directly calculate. This is called the bandwidth. If it is given in the hertz, then what will be the bandwidth in hertz? f0 by Q. f0 by Q. So what is the answer for this question? Bandwidth is given by f0. What is f0? 1 kilohertz means 1000 hertz divided by 5. 200 hertz is the bandwidth. 200 hertz is the bandwidth for this question. Okay. And remember this diagram. For series resonance, we are having this type of curve. Okay, if the quality factor is high, then This is FH, this is FL, this is the maximum gain, or we are saying that we are getting in a resonance circuit we are getting the maximum current at this point, and at that point the current will become 1 by root 2 of the maximum. This is called 3 dB cutoff frequency, and that time is called bandwidth. If the quality factor is too high, then this is the exactly bandwidth by 2. This is exactly bandwidth by 2. It is a symmetrical for the high quality factor. Then if once you have the bandwidth, you can calculate the FH, that is nothing but F0 plus bandwidth by 2. And FL, lower cutoff frequency, is given by F0 minus bandwidth by 2. Already we have calculated the bandwidth. The bandwidth is given by F0 by Q. That will be the formula. Okay. And then my dear friends, in a simple parallel resonance circuit, the formula will remain same. Formula will remain same, but simply quality factor, this formula. The formula for the quality factor will change. Formula for the bandwidth will change. What will be the formula? Simply replace, this is the series, this is the parallel resonance. Replace R by what? 1 by R. L by what? C. And C by what? L. That is the simple concept. Then in that case, the general formula will remain same, omega naught by Q or F naught by Q in Hertz. Okay, but what about the quality factor for parallel resonance circuit? This will become R by omega naught L or omega naught RC, right? That will be the quality factor. Okay, and the bandwidth 1 by RC, 1 by RC. Here it is a R by L, here it will become 1 by RC, that is in radian per second. Bandwidth in radian per second. So this is all about the series resonance, parallel resonance and steady state analysis of the sinusoidal signal. Now my dear friends, you are on BYJU'S exam prep, the most comprehensive app for all exams. Like the session, share the link of this session and subscribe our channel. Tomorrow we have very important session at morning at 8 p.m. If you are interested, then you can join 8 a.m. Early morning at 8 a.m. Right? Diode circuits. Within 6 days, we are going to get the command over the complete diode circuit, and that is important topic from analog. Right? And basics of the diodes already over, so please watch that session. And then tomorrow we are going to start rectifiers and filters. After that, clipper, clamper, voltage doubler, precision rectifier, each and everything we are going to discuss. So you are on BYJU'S exam prep. Thank you and good day.